Okay, so on the back, some stuff that we haven't worked with for a while. Okay. So, 4 questions here, they're all true, false. First question, is BC parallel to DE? So we want to know if this line right here is parallel to that line right there. Okay? What would be true if they were? How would you know?
9/6 equals 6/4.
Right. This triangle right here would be divided proportionately if those lines were parallel. So like Alyssa said, that means 9/6 would be equal to 6/4. Is 9/6 equal to 6?
Yeah.
Yes. So that means this is true. These two lines are in fact parallel. Okay, next one. How about BC parallel to FG? So now you have to be a little bit careful with this.
It's 6/6.
I want to know if this line right here is parallel to this line right here. So I have to completely ignore this line in the middle. Okay? So it's going to be, what I need to figure out here is 9 over this whole side right there. The distance between B and F. Okay? So 9 over, 21. Does that equal 6 over this whole distance right here, which is 16? Whoops, and I wrote 12. Okay, so if you cross multiply one way, 9 times 16 is 144. If you cross multiply the other way, you get 126. Are those two lines parallel?
No.
No. So the answer to B is false.
We don't have to explain why, do we?
Nope. You're good. All right, so now we're going to reach way back and say, is ABC, so let me get rid of some of our markings here. Is ABC, this triangle right here, what does that little squiggly thing mean?
What's really big?
What?
Oh, similar?
Similar, yeah. One little squiggly thing means similar. Is it similar to that one right there? Okay? And from the work that we did in part B, we know the answer already. What is it?
No.
It's no. Because these two lines here are not parallel to each other. So that means that this angle is not the same as that, and this angle is not the same as that. So that means that the answer to C is false. Okay?
D would be false too, but
ADE to the whole, well, we have to check that. So now we're trying to figure out, is this triangle right here, ADE, is that triangle similar to AHI, the whole big thing? Well, we haven't figured that out yet, right? We don't know if this line is parallel to this line or not. We didn't check that in the other thing. So let's do that right now. So the side of this triangle is what?
What do you say?
The side of this triangle is what? How long? 15. So that would have to be over this whole distance here, which is 21. We want to check and see if that equals this distance right here, 10, over these two added together, which is 14. Okay? So if you cross multiply those, do you get the same answer? Yes? Okay. So since these two lines are parallel, what's true about the two triangles?
They're true.
They are similar, so it is true. Okay? Okay, number 2. Oh, this is a good problem right here.
Not really.
Yeah, it is a good problem because you have to really know what you're doing.
You need the 90-degree angle.
It's really awkward to be quiet in a classroom. That's really awkward. All right, somebody help me out. What do we got? You've already done one like this. We should be able to get W really quickly. Yeah.
4.
4 root 2, good, because this is a 45, 45, 90 right triangle. So this is 4 also, which means the hypotenuse is 4 times the square root of 2. Okay? So right off the bat you get that one. Okay.
5.6.
I don't know off the top of my head what 4 times the square root of 2 is. It's probably about 5.6, yeah. Okay, what about x? Because now we have a what? 30, 60, 90 triangle. And how does the short leg relate to the hypotenuse in a 30, 60, 90?
Oh my god, I hate that.
Okay, how does the short leg relate to the hypotenuse in a 30, 60, 90 triangle? It's half. Good. So this would be 2 times the square root of 2 because that's half of 4 times the square root of 2. Okay? Woo! Now, how does this thing right here relate to this short leg right here? Times root 3. Okay, so it's a short leg times the square root of 3. So that's going to be 2 root 6. Okay? And now things get really crazy. In this 45, 45, 90 right triangle, we have these 2 legs. Alyssa, you with me? Come on now. We do these 2 legs, and so we figured out the hypotenuse was the legs times the square root of 2. So now if I know the hypotenuse of a 45, 45, 90 right triangle, I want to find the legs, then I have to divide by root 2. So what's 2 root 6 divided by root 2? 2 root 3, because I can only divide the like term thingies. So z is 2 root 3. So that was a tricky one. You got it? You get them?
Yeah, I'm
In like decimals.
Oh, okay. It's not hard to do.
No, I don't.
Well, I did it the opposite way.
No, I mean, it's not fun to make, or not hard to make fun of Alyssa.
Oh, I know.
Yeah, but,
I got him in the actual decimal.
yeah, decimal's fine. Oh, no, sorry, it's not.
Yeah, I know.
No, it says find the exact values.
Yeah, I did.
Okay,
I
so
put
you
all
gotta
of
keep
them.
the square root in there for. Did you say a decimal is more accurate? Okay, number 3. We are given the vertices of a quadrilateral. -4, 0, 6, 10, 2, 10,
Do we have a sub
and
tomorrow?
-4, 4. What?
Do we have a sub tomorrow?
Uh-huh. Seriously. Because of golf.
Where are you going?
Going to Olympia.
What state are you
Week and a half. What kind of a quadrilateral do we have? Trapezoid. Okay. Be more specific.
What?
Be more specific. Nope, no right angles in there, not a right trapezoid.
You can't have.
Yeah, you can. What kind of trapezoid? No, you can have a right trapezoid, that's fine. You could, yeah, you could be like this. That's a right trapezoid. Okay, and these 2 are parallel. Okay, we do have a trapezoid because this line right here is up 1 over 1, up 1 over 1, up 1 over 1, and this is the same way. So those two have the same slope, so they're parallel, but we can do better than that, yes. Okay, anybody got it? What's true about this side right here and this side right here? They would be perpendicular to each other. They're what? They're more than similar. They're equal. Okay, so this side is congruent to this side right there. So what kind of trapezoid do I have? An isosceles trapezoid. Okay, just like an isosceles triangle has two equal sides, an isosceles trapezoid has two equal sides as well. Okay, so that's actually an isosceles trapezoid. That's the answer.
We don't have to do 4 and like 6.
No, let's not do 4. Let's take a look at number 5. So number 5, we have a right cone. It's got a height of 4 and a base of 3. And it's dilated by a scale factor of 1/2. Okay, so that means that the all the dimensions are cut in half. So now we're supposed to figure out the volume and the surface area. We could use that fun relationship between sides, area, and volume, where the area is squared and the volume is cubed, right? But it's probably easier to just change these dimensions. If it's dilated by a scale factor of 1/2, what's the new height going to be? 2. And what's the new radius going to be? 1.5. So now to find the surface area, what's the formula for the surface area? Nope, you're close to the volume there. Is 1/3 the area of the base, which in this case is pi r squared times the height. Okay?
4 pi r squared.
Okay, isn't there a fun, easy one with a slant height? R plus the slant height times pi times r, like that. Okay, which is the same thing you just told me, but it's written in a little bit different form. Okay, so what is the radius of my new cone? 1.5. What's the slant height? Nope. Oh, would it be?
Oh.
No, because this is the hypotenuse, so you know it's going to be bigger than both of these. Yeah. No, because I don't know these angles. I don't know if I have a 30, 60, 90. I don't know if I have a 45, 45, 90. Right? I know this is a 90, yeah, but these angles could be anything they want.
It's inside of a circle.
Yeah. No, I don't know it's a 30. I could make a cone, and I could have it be a big, fat, short cone like that. Okay, and now this angle is going to be different, or I can make it a really tall, skinny cone like this, and then that angle there is going to be different. So this triangle can come out to be any kind of shape I want it to be. Okay, what did you say it was? 2.5. How'd you get that? Right, this originally was 4 inches, this originally was 3 inches, so this is a 3, 4, 5 right triangle to start with, and then we dilated it by a scale factor of 1/2, so then this would become 2.5, okay? So it's going to be 1.5 plus 2.5 times pi times the radius again, which is 1.5, so you can figure out what that is on your own, on a calculator. And you can also figure out what the volume is on your own, okay? I don't know, that looks pretty wacky, doesn't it?
Yeah. No, trust me.
Okay, so let's, we're kind of short on time here too, so we'll call it quits there, all right? Okay, so big fat test tomorrow. You can hang on to these if you want to use them to